couple of things related to temperature is that ambient temperature is basically the same as the local air temperature, okay? It's not the surface temperature of the particular item that you're analyzing, okay? Bulk temperature, basically, that refers to when you have a thoroughly mixed liquid gases. That's what I mean by the bulk temperature outside of particularly what we're talking about in terms of convective and that type of thing. It's important to note too, to save you a little time on the exam, you'll see Rankine, which is some requirements on the in the equations. The point I'm trying to get with this is delta T for Fahrenheit is the same as delta T for Rankine. So in other words, to save yourself, I'm a big believer. The less keystrokes you put in your calculator, the better off you are. The less chances you're going to have for a mistake. So basically, delta T is the same. Save yourself a little bit, instead of converting both temperatures to Rankine. You're adding it in both, you're subtracting it off, so just it's the difference between them. The same thing with Kelvin and Celsius and Kelvin. Right? But anyway, heat always flows from a higher temperature to a lower temperature. And the key takeaway on that, you've got that in there. Typically, I mean, I've got the conversion factors in there. You add 460 for Rankine and Fahrenheit, and 273 for Celsius and Kelvin. Typically, they don't give mixed units. In other words, don't say that the surface is 100 degrees centigrade and the bulk temperature on the outside is 30 degrees Fahrenheit. They typically, that's mixed units. They don't do that anymore. If they do that, I would jump up and yell and scream at them. No, they're not going to listen to you during the exam. You're in your room by yourself. Well, no, you're with a bunch of other people. But anyway, key takeaway on this thing here is that Kelvin has the same incremental scale as Celsius. Okay, so in essence, 1 unit of Kelvin is to say as 1 unit of Celsius. The point I'm trying to get with that is that you'll see problems given in Celsius, and then it can say the conduction, thermal conductivity may be in degree Kelvin. And everybody goes, well, what happened there? It doesn't matter, okay? You can still use the value to it. That's really the key takeaway on that little box there in red.